in the power electronics lab. So I will request kindly give focus on here single phase converter firing unit, and where we can get four pulses, 1, 2, 3, 4, right? And these four pulses actually we have removed that board. And can you come here this way? We have removed the board so that we will know exactly what is the problem, and ultimately we find that there is the Zener diode over here. These are the pulses 1 and 2, and these are the pulses from 2, 3 and 4. And here this one Zener diode is actually get faulted because of short circuit or overload in the thyristor, and the gate side this Zener diode get break and we need to remove it. Zener diode is having, like, if you test in the multimeter with if you test in the multimeter like this, like if you give a multimeter and you connect here in the diode, measure like this, right? So if you measure between the two ends, you will get 0.5 volt. Two end means the anode and cathode, and if you take the diode, there also you will get 0.5 volts. And like we will try to see here, but right now it is the on condition. We need to turn it off. Let me turn it off. Right, and now if I will see through that multimeter between the 2 point of the Zener diode, can you focus on the multimeter please? Multimeter here. Uh, so if I point these two, you will get 0.5, right? It is coming 0.477 volt. So that was a faulty one, and we have replaced that faulty one with a new. This is a very cheap, it is a hardly 1 rupees cost of a Zener diode. We replace that, and after replacing, what we are going to see is that waveform of these four pulses. Earlier we have replaced these SCRs, where we are supposed to get between the anode and the cathode in mega ohms during the off time, and between the gate and the cathode we should get 47 ohm. So this is where we get a faulty over here. This get failed, and anode to cathode is showing only like short circuit. When there is a gate pulse, then only this should behave. The resistance should be nearly 1 ohm or less than that. But if the gate pulse is not there, this resistance between this middle and this left one should be in 1 mega ohms. So these two we have replaced, and that what this board is completed. This entire board was completed. In the previous video we have shown that. So here now we will just see that in multimeter, because the lower two gate pulse having a problem. So I am connected it to T2 dash and T2 here, and we will see that what is the, okay, let me turn on first. Let us turn on the model. So when we turn on, it will say like welcome and single phase converter firing angle 180 degree. So we need to turn it on and decrease the firing angle. From 180 it will need to be decreased from 180 to 0. So once we are getting 180 to 0, we will be getting the output pulses over here. So one can see simultaneously. Okay, let me decrease here first. What you can see here on that CRO screen, you can see that these this is the second channel and the first channel. I'm decreasing it so that we can clearly see that. So here the 5 volt. So here what we can get is a 5 volt over here. So now if I will decrease this firing angle, so what you can see is that there is a change in that duration of gate pulse, right? And that is what we are not able to observe the same before the fault occur. So after we change it, replace the Zener diode, we are getting a very good output here. So simultaneously 2 dash also we would like to see simultaneously. So both the lower pins T2 and T2 dash is being reflected over here. So when we pause it, so they should be triggered at the same time. That is why you have got the lower T2 and T2 dash. So here I will request sir to show you. This is T2 and this is T2 dash. These two should turn on at the same time. And this is what we can see, that they are turning on at the same time, both having the 5 volt over here, right? So actually it is written here 10x, but in the proof we have minimized it to 1 by 10. So that is actually 5 volt is what reflected here. So if I want to see the other T1 and T2 also, which are healthy, which was earlier healthy and we haven't touched anything out of it. So let me just change this from T1 T2 and see that what is the output we are getting. So similarly, the same thing T1 T2, we will get this, we should get the same pulse like this is synchronous. So you can see that T1 and T2 T1 dash, sorry, T1 and T1 dash, they both should be turned on simultaneously. And now we will see that one of them, like T1, another we will take off to T2. T1 T2 should be out of phase. So if we connect together, we will see that T1 T2 was out of phase. So you can see that when turning, one is off, another is turned on with some dead time over them. That is not necessary, but for the inverter it is very important. Now what I am going to do is I will try to uh, increase the firing angle from 0. I will try to increase and see that how the output is changing over here. Kindly focus here only. So now it is 14 degree. Let me take some appreciate angles like 45 degree. Okay, now it is 45 degree here. So you can see that when it was 0 degree there is some pattern, and when it is 45 degree there is a gap is more. When it is 0 degree, that equally, it seems like equal, wherever time the positive, the yellow was there, same time the blue was there. So T1 and T2 pulse of the same duration, and the width was completely like for half the cycle. Now the width has been reduced to lesser value. So more and more firing angle, if I will increase here, suppose I will increase the firing angle more and more. So from 45, let us make it 90 degree. Yeah, 91. Okay, let us make it 90 degree. So we can see that here how the pulses are looking like here. So what you can observe that these pulses width has been changed to a very lesser value, and that actually increasing, actually when it's a 90 degree, it is actually changing the firing angle. The firing angle is after 90 degree. So instead of having 0 degree firing angle, the blue one, we can see that it is firing after 90 degree. So that is what is a change in that, by changing the firing angle we are getting like this. So it is not visible here that which degree it is, but we can obviously see that there is the pulse width is getting, turn on time is getting smaller, and that means alpha is increasing. Okay, so this is all what we are ready. We will see that this instrument will work in the another cycle. Yeah, thank you very much. In the